warm welcome to our course Geography and Spatial Statistics, NPTEL SWAYAM. Principal Investigator, my friend, Senior Professor Sulochana Shekhar, Department of Geography, School of Earth Sciences, and Co-Principal Investigator, myself, C. Vijayalakshmi, Professor from Department of Statistics and Applied Mathematics, Central University of Tamil Nadu, Thiruvarur. Critical thinking is the process of deliberately and rationally analyzing the information related to geography, arguments and assumptions to form sound judgments and making informed decisions. It also involves different types of category like questioning, interpreting, evaluating the information to understand the connections between ideas, solve the problems and thereby avoiding the biases leading to better outcomes. What are the major key aspects of critical thinking? Analysis, evaluation, inference, reflection, problem solving. So how are you going to deal with critical thinking in geography? Mainly, it deals with understanding the spatial relationships. We offer the critical spatial thinking to analyze how objects and phenomena are distributed and related across the space, considering the different types of factors like location, distance, direction and patterns. Moving on to the next concept of multiple perspectives. The key aspect is considering different geographic perspectives to develop a complex and nuanced understanding of global issues and systems. How we can ask different types of questions related to this critical thinking as a theme with respect to geography and spatial statistics. Critically thinking, we always try to see why the things are located and where they are, and try to investigate and understand the causes and interactions of place and spatial patterns. When we just enter into GIS, Geographic Information Science, first thing we have to think about data interpretation. Critical thinking is vital for interpreting the maps, spatial data and the outputs of GIS, understanding their inherent complexities and the limitations. How we are going to assess the data? So normally we evaluate the data for its accuracy, relevance and completeness so that we can ensure the analysis and decisions are well grounded. Then we have this problem solving. It enables the use of GIS to solve complex problems by listening to the right questions, identify the assumptions and logical hypothesis to be framed based on the spatial data. When we just talk about how critical thinking play a vital role in spatial statistics, identifying the assumptions, it tells us like what type of statistical models have to be implemented to understand the potentials and how we can interpret the spatial patterns. That means we find out the spatial patterns, reveal what type of correlation or the relationship exists versus causation in spatial data. How do we go in for evaluation of the results? This determines the validity and reliability of statistical findings, including whether the patterns are statistically significant and under the concept of geographic context. What are the basic skills we need in this is like inquiry, evaluation, synthesis, and thereby the skill to combine the information from various geographic and spatial sources for coherent understanding. The reasoning also helps us to make the capacity for a clear and logical, well-supported judgments for spatial problems. Thank you all.
Hi and welcome to Geography and Spatial Statistics NPTEL SWAYAM course. I am Professor Sulochana Shekhar from Department of Geography, School of Earth Sciences, Central University of Tamil Nadu. My co-PA is my friend Professor C. Vijayalakshmi from Department of Statistics and Applied Mathematics from Central University of Tamil Nadu. So we offer this course under critical thinking. This course is for geography students, statistics students, as well as geographic information science and computer science students. Geography and spatial statistics are intertwined fields. They rely on each other for insights, methods, or even foundational knowledge. Geography utilizes statistical methods to analyze spatial data, which includes information about the locations, shapes, and geographical relationships. Spatial statistics focus on understanding the patterns, relationships, and the processes that occurs across the space, considering the influence of location. What is this location? Everything that happens on somewhere on the Earth's surface. For example, if you talk about a natural phenomena like a volcanic eruption, a tsunami, a flood, or something like man-made events, some road accident, some crime, the first question arises in our mind is where it is happening, the location. That is very, very critical. Location matters to take an informed decisions. And again, the spatial is always special because in the statistics we use the data, but when you add the spatial information, that gives a meaningful inferences. Spatial data represents features on the Earth's surface, including points, lines, and polygons. For example, if I say from your house to your workplace, how you map the area. When you mark this house as a starting point, your workplace will be the destination point. So when you starting point to destination point, you will be connecting the roads by using the lines. So this point is representing your house or your workplace or some campus. So that can be even a point or sometimes representing the area as a square or a rectangle like a polygon. So point, line, polygon. These are the simple way we represent the real world. By using this spatial data, we'll try to understand the patterns, the trend. Suppose the crime is happening or the road accidents are happening. So what is the trend or what is the pattern happening in these events? Similarly, we can analyze the relationship between the event as well as the surrounding. So the spatial analysis help us to understand the distances what we are measuring, analyzing the spatial autocorrelation and many more. Coming to geostatistics, which is part of the subfield of spatial statistics, also analyzing spatially correlated random variables. So how it can be applied? It can be applied in various fields, including public health, environmental science, and urban planning. Now coming to the content of this course, it has 5 units. The first 2 units talks about geography and the spatial data. So you will understand geography, it is not just memorizing the fact or description of the earth. It is much more beyond this understanding. So you will get a new dimension about geographical laws and how it is going to use in spatial analysis. So the second unit is completely devoted for spatial data analysis and spatial analysis of different characteristics. For example, so when you talk about the second unit, it deals about the geographic information science. So we'll give a brief introduction about geographic information science and the spatial analysis. So the spatial analysis is very, very important for understanding the real world problems and finding about suitable, sustainable solutions. The third and fourth unit is completely devoted for software package like R. So this help you to understand and visualize the data as well as analyzing the data to find out the relationship between spatial data and the other parameters. It enhances the understanding of geographical phenomena and their implications. So R is a free software environment for statistical computing and graphics. It compiles and runs on a wider variety of platforms including Windows and Unix platform. It is a programming language and environmental designed for a statistical analysis, data visualization and machine learning. So in this third and fourth unit, we will be understanding about R and even the various machine learning techniques including SVM, random forest and deep learning. So upon completing this course, the students can understand the basic spatial statistical approaches, principles and main traditions. They can able to distinguish different types of spatial data and understand how this spatial autocorrelation plays an important role in statistical modeling. They are able to determine which spatial methods to use to their own research and implement them in using statistical software and geographical information systems. They can learn and use R in spatial statistics. They can apply and critically examine the real world scenarios and take informed decisions. So this course doesn't need any prerequisite. So the students from geographic background can also work on R software package. Same way, the computer science students can even understand the geographical concepts in a better way. So I am very sure that the students who are enrolling for this course will enjoy learning the geography in a new dimension and also able to handle R programming software, and they are able to analyze the real world situations in a better way, informed citizens. Thank you.